Hello everyone, thank you for coming here. Today you are in the classroom, by the end of the session you will be in the boardroom. So that's the promise. The second promise is that zero slides. No slides, so we want to do similar session where only demos. We want to show you the power of Azure SQL DB as the life cycle of somebody starts with a classroom where they're learning stuff, they want to get to their knowledge, they want to build their career, and then eventually they grow through the stages and end up in the boardroom. So that's what it is, from the classroom to the boardroom. First, let me introduce the student who is starting in the classroom today, is Silvano. So he's going to walk through, as a student, when you start learning and you start building application, first of all, what you don't have is a money. You probably don't have ability to buy this subscription here, that thing here. So what we have for you, something that you can download and put it on your device and simulate as if you are developing in Azure SQL Database in the cloud. Silvano, take over.
Let's go. Yeah. As I'm kind of representing a student here, all the cool students today are using VS Code as part of their development life cycle, right? So I have it open right now. I'm leveraging a couple of extensions, the SQL Database project and the MS SQL extension to connect to the database. And I can actually start developing my first database by creating a new database project, selecting Azure SQL Database as the target, and entering a couple of information like my project name, where the project location is. I'm going to use the new SDK style for my project, and now I'm ready to start designing my database, right? So I learned something around tables, so I'm going to add a couple of tables to my project. I'm going to create a books table, authors table, just to catch, and collect my books in my library, right? And I'm going to create a join table for multiple authors writing the same book, and I'm going to extend those three tables as I'm learning how to deal with attributes, data types, and such, right? So this is my data model that I'm going to build an application and test it all locally on my own machine here, because my school doesn't have great internet connectivity these days. And I want to also start introducing, inserting some data. So I'm creating a post deployment scripts. So I'm going to basically load some test data on my database, right? And once I'm done with this, I want to start testing. But first of all, I want to make sure that my project will work with Azure SQL Database. So I'm selecting Azure SQL as my test, my platform of choice. And now what I can do is actually build my project, right? So the build system on my local machine will tell me if my code is actually compatible with Azure SQL Database once deployed in the cloud. But I can actually do more. Once the code is ready, I can publish it on the local Azure SQL Database emulator, right? Where I'm just selecting a couple of informations, entering my admin password for the local database, and pick up the right database emulator image. The full ones looks great here, and just accepting the license and picking up the latest bits that we have available on our container repository. Database name is here. I can, deploy now, start deploying and publishing my project on my local database emulator, where I can now start running tests, right, and validate my database design based on my application requirements. I'm deploying the DACPack right now into my local instance. DACPack is representing my database model effectively, and in a second we should see. Now, the DACPack succeeded. Now I can start looking into my database, and effectively, I have the local instance in place. I have my tables deployed. I can actually start, running some test queries, and the database is up and running, right? So I have database deployed. I have it locally here on my machine, right? And what I can do now, I can also, start writing some code or some application code, right, in order to test it. And we should go there in a second. Here we go. here we go. So we have an API, right? I wrote a very simple API using .NET, and I'm using actually also Entity Framework in order to scaffold, reverse engineer my database into my .NET code, and the app is up and running, and I can test it. I can, run a query against my books API. It works fine. It's just returning my books. I also can build a test project, a unit test project, and make sure that all my tests are actually passing. So now I'm done. The local development is over. I'm ready to start publishing my code into Azure. Right, and I'm going to start from the database project, where I can now publish not on my local database emulator anymore, but on my public Azure server. Right, so I'm going to select my connection details here, and select my new database in the cloud. Click publish, and after a few seconds, the same process that I was using to publish the database here on my local machine is going to push that database model into Azure Public Cloud, and we can see that the database is showing up in my Azure SQL Database in the cloud using the same tool set that I was using before, and effectively the books are there, the authors are there, and my database is now up and running in the cloud. So it's now someone else's turn to kind of develop the full application around that.
Awesome, fantastic. Now this is the way you learn Azure SQL Database from scratch. This is a project that was actually inspired to us through COVID times. Through COVID times, people were working from anywhere. Sometimes they have a connection to the internet to be able to deploy. Sometimes they do not have. Sometimes people are working from beach. Sometimes people are working from a national park, from a camping site. So we created a simulation of Azure SQL Database that you can just have an image of it on your laptop without any connectivity, develop, and then when you are available, push it up. Okay, good. Now, what is happening to our learner? Now, this is what happens when you learn Azure SQL Database. You start getting ideas that, okay, what am I going to do in my career before? Now, this cool kid has now come up with an idea that, okay, this will become a big thing in the future, and therefore, what we need to do is that even build more muscle into our development, build APIs, how to think about how do we deploy them in the cloud, and etc. So David is going to walk us through building APIs and stuff like that. So
is that on? Yeah. Okay. Cool. Yep. So I'm a cool kid, so I want to create a full website to basically publish the book I have. If you remember, a few years ago, there was a very nice application. I don't remember the name right now, but basically allowed it to you to keep track of what book you have read, what book you have borrowed to your friends, what book you are interested in. So I want to build something like that, but modern, right? And Silvano showed something great, so I can use everything on my machine. But I am absolutely in a startup mode, so I need to act fast, and what I need to do is create an API that my fellow front-end developers can use to create a super nice website, right? Unfortunately, the API, it's something that is kind of complex to create if I want to do it well, because I need to support proper pagination, selection, filtering. I need also to, hold on a second here, also to support the ability to create, update, and delete all the stuff, right? So it's a little bit of a complex, and again, I want to move fast, break things, I want to be ready tomorrow, and I already have a beautiful front end, so I really need to build a back end from the table I have already, right? That's why we created and we made public yesterday a tool called Data API Builder. That is what I'm going to show you right now. Data API Builder is open source. It's free to use if you use it on your machine or any cloud where you self-host it. Of course, you can easily host it on Azure. If you host it on Azure, you can use it with static web apps, which is the perfect complement because allow me to take whatever I have done on the back end and create a very nice front end and just host it in Azure, again, since I'm a student, for free, okay? So let's see Data API Builder in action, starting from the table that I have. So I have the usual table for the books, for the authors, for everything, and everything is running on my machine. And I want to make sure that whatever I build can run on my machine before starting to figure out how to deploy it on Azure, right? So yeah, okay. Perfect. So I have the books, the authors, maybe it's better if I just look from here. And I have also the series. And I want to build something that put everything together, just allowing the API to allow you, who are building my front end, to query this data. Okay. So let me show you the books, the series, as just mentioned. So these are the books. I also have a series ID that connects my books to my series. And of course, I have my series. I'm a science fiction fan, as you can see. So I have added some Isaac Asimov books in my samples. And I have to download Data API Builder. It's super easy to do that. .NET tool install. I already have it on my machine. So it just complains that I already have it. I don't have to download it. But literally, to have it installed on your machine is .NET tool install. That's it. Then you do one thing. .NET dab init. Dab is short term for Data API Builder, is our CLI. And it will initialize your configuration file. Configuration file is all we need to save into this configuration the fact that it's not that we want to publish all our tables, because some needs to be preserved from public usage. But we want to publish books. Make sure that anyone can access the books, and the REST endpoint I'm publishing, because I talked with my front-end guys, then they will be querying an endpoint called books with a small case B and with a final S, needs to be named that way. So Data API Builder can basically flex to adapt to my needs. And that's it. Now I have a configuration file. Now you may see that I have another one because I just want to speed a little bit the demo, speed up the demo, and show you other stuff. But this is the configuration file. It's just a configuration file, a JSON file, where you can basically, first of all, you can create it on your own if you want. So you don't need to use the CLI, because we also publish the schema. And the only thing that is contained is the information about the table and the permission, and other metadata like the path at which this endpoint will be available. Now you do dab start, and Data API Builder is starting locally. As you can see now, is listening to a couple of endpoints, one HTTP, the other HTTPS. Of course, we recommend to use HTTPS. And now I'm using a client. This is a free REST client called Insomnia. You could use Postman, you can use curl if you want. And I have my table available as an API already. That's it. I deleted a book. I now query my book. Everything is happening at the API level and is sent to the database behind the scene for me. I can even use GraphQL, which make everything super cool right now and super efficient, because I can, as you will see later, I can even query related entities using GraphQL. So I can, in just one request, I can have multiple data sent back, which is a great thing for example, making efficient use of battery power in mobile phones. But now I want to make sure that you can only see the book that I allow you to see. I want you to be a library manager in order to manage the book, right? So there will be a public face of the website where anyone can see anything, but only if you are in the library manager role, you will be able to do something. So Anonymous will only be able to read. Library manager will be able to do everything. Okay? So that's what I'm declaring. So as you can see with Data API Builder, I'm saying what I want, and Data API Builder will actually take care of creating the right API for me to do whatever I want. I'm also creating a relationship so that from the books, so in that case from the series, I can take I can have a list of all the books related to the series, and of course I'm doing the same on the book on the other way around. In a book, I may want to understand to which series it belongs to. Now, that's all I need to do. And here, I just have to now restart the Data API Builder using the updated configuration file that will also use Azure Active Directory to authenticate. And now it's started. And if I use again the Insomnia client, everything is still working perfect, of course, because I'm reading, right? So I can always read, because I said that anyone should be able to read. But if I try to post and I'm not authenticated, I will get a 403. It's forbidden. I can't do it because I don't have the permission. How do I get the permission? Well, first of all, I can just authenticate against Azure Active Directory. If you are building a front end, there are tools that you can do that. Since here I'm not showing the front end, I just use the AZ CLI to get my token. And as you have seen, in my token, there is the role. So when you authenticated against Azure Active Directory, you have been given a role. And the role is inside the token. As you can see, if I don't pass the token, there is no role, and I am not authorized. If I pass the token with the right role, of course, I get authorized. In this case, I have an error. You are saying to me, bad, because you are showing some information about the database inside, and that information disclosure. That's because we are, because that was an error, right? That's because we were in development mode. Development mode brings up all the error. So you can easily debug it. If you switch to production mode, all that errors will be available in the log that I will show you in a second, but not surfaced to the end user. An end user will just say, okay, you couldn't do that because you were unauthorized or because there was an error, but in a very generic way. So, and that's how you can get an access token that I was mentioning before. And the resource is the audience that you have specified. You're familiar with Auth2 here, which is the way we do authentication over the web. And as you can see, I have configured my Data API builder to say you need to use AAD and specifically to this audience to authenticate against. And when you do that, you will receive a token that has all the information needed. And now, what I want to do is also show you what happens behind the scene. So on the left, I have the log generated by Data API Builder. On the right, I have the log generated by Data API Builder. On the left, I have a JSON GraphQL query in this case. And what I'm doing here is that I just want to have all the books, but I want to filter them. I only want to see the books for which the title contains SQL. Actually, no, I think I have to do foundation here. Yeah, let's say foundation. So that is the query that my front end will be sending, and the result, and this is the query we generate for you behind the scene and issue to Azure SQL in this case to get the result back. And we do this in real time, of course, it's pretty fast. If you take a look at the latency, it's usually in the low hundred of milliseconds. And basically, this allows you to completely take any table, any view, any storage procedure, and securely, since we support authentication, turn it into REST or GraphQL API. All on my machine. Now, what I need to do to publish this on Azure, just take the configuration file and push it to a GitHub folder, use static web apps, and I'm done. My database is available as an API in Azure. In 3 minutes, 4 minutes, let's say 1 hour.
6 minutes.
That's pretty cool. 6 minutes.
6 minutes.
Any question?
Thank you.
Yeah.
We are,
Okay.
we are going through, and then we'll take the questions at the end. Good. Thank you, Davide. So what you saw is that building APIs, modern application architectures is super easy when you start with Azure SQL Database. What you will also see in Azure SQL Database is that what Davide was showing you was that lots of JSON. Things coming in, JSON, things being represented as JSON. Because that's the way it is today. APIs, microservices, modern application architectures love to talk the JSON language, love to talk the JSON, the data being transported back and forth in JSON. So what we have done in Azure SQL Database, Azure SQL Database had a pretty decent JSON capabilities. But in recent updates, what we have done is that we have enhanced. We have introduced a lot of features that makes it easier for you to take JSON out of Azure SQL Database. Data could be stored in relational database, which is the case in Azure SQL Database. And you can convert that into JSON, take it out wherever you want to take. Or JSON data could be coming in, and you want to convert it into the best format to store data inside a database, which is the rows and columns, and it can do that easily for you. So we have introduced this new set of 4 functions. They're available also in SQL Server 2022. And I'll show you some demo how we do that. So we are just starting with a table. and giving you some examples of the new function into each JSON, which checks if an expression given to this, if it is a JSON formatted or not. Then if there is a path exists or not, and then how to convert this into JSON object, and how to convert something into an array, and we'll show you an example of where you need a JSON array type. And so step one, we will create a table and insert some data into it. And later on, we'll show how to convert that data from relational format and create JSON output for it so that you can send it. Now, this is the example of it is coming in. So you see that all we have done here is that actually an expression of JSON that is a variable, and we're going to check if this is a JSON formatter or not. So yeah, you have done your curly brackets, your commas, and everything else, but SQL provides you a way to see is it JSON. So it's going to check you, and then it's going to tell you if this is or not. You can also check if a certain key exists within that the JSON expression that has come to you, and that is JSON path exists. So it can do all those parsing for you even before you have taken data inside the database or got anything outside the database. Now that you have got those things checked, what we're going to do that we are going to transform the input JSON that has come in and insert this into database. And it's the same JSON statement that you see. We are going to insert into order table where we are storing actually the JSON that is coming in, and then we're going to convert that JSON and make sure the insertion happens in the table. Yeah, so you basically see the JSON expression is being parsed. The different component of the JSON is being reflected into different column within your table definition. So the right column goes to the right value goes to the right column, and then we execute it. Once we execute it, you'll see that so 2 rows. We had 2 JSON objects that has come in, and then we are able to insert 2 rows into the table. Now what we're going to do is that, okay, what if I already have JSON inside my table? I want to express it in a JSON form and transform relational data into JSON basically. So Azure SQL Database have this principle: store the data, the best way to store it; communicate the data, the best way to communicate it. Storing data is best for querying purposes in rows and columns format, because you all know that. A lot of us has been doing that. Communicating with microservices and communicating with these APIs is best done using JSON format. So this is, I already have data in the table. I'm going to convert it into JSON before I send it to an API or send it to any other consumer. So if you can see, all it did was that we selected from the table, and all it gave me was a JSON string, which is an output from the data in the table. And now if you click on that, actually Azure Data Studio can actually show you a formatted JSON object as well. Now what we're going to show you here is actually that sometimes you get a, I would say, not very nested JSON objects, but sometimes you get nested JSON objects. And when you get nested JSON objects, we use the JSON array function to be able to recognize that, okay, I have one JSON object, but it actually consists of multiple stuff inside it so that it can parse it appropriately. So why we did that? Because now that you have grown from the classroom to the next stage of discovering an application, and then you want to build more complex application architectures, and then want to build that into cloud, what you want to do that, you may need to introduce more functionality and complexity, and that's why all these additional features of SQL comes into the picture. Now that your application is ready, we want to do the DevOps and take it to the cloud. Moazma, take it over.
Okay, so before I go into the details, let me just paint the scenario. So we started as a student. We had one developer, one person working on their local computer, building on Mac OS, Windows machine, whatever machine you have. Then you had an idea of building a web app or some other kind of application. So you looked at REST, GraphQL, some fancy stuff. Then you added JSON payload to it, and then your application is working. Now you have 2 or 3 developers, they have come up with an idea, and then you're moving to the next level of your idea to converting into either a company or it's part of a team where your organization is growing and you're hiring more folks. In that case, you need to think about the developer lifecycle. So we call this as an abstraction layer of inner loop and outer loop. So when developers are working, they're thinking about their own check-ins, the work that you own, maybe an update to a stored procedure or the app side of things. And then there's another person in the team who's responsible to maybe update the indexes or table schemas and things like that. So there is going to be merge conflicts and things like that. So you have to think about the DevOps lifecycle. So I'm going to show what that looks like in terms of SQL projects that Silvano showed you when you started in the local environment. And then how do you actually make it part of your CI/CD life cycle and then include that in your DevOps life cycle to make sure it works in your deployment environments as well. So starting in this case, we have, we have build SQL projects. This is kind of the environment. This is what it looks like. You can go find out more information about it. Right now, I'm using the SDK style SQL projects, which is in preview. Really highly recommend for all of you to look at that. And then you have certain other things in this. So I'm going to go ahead and create a new kind of, in this particular case, you also have some post-deployment scripts. So not just your tables and indexes, but there are deployment scripts as part of your DevOps lifecycle. So what I'm going to go ahead and is create a new column in this, which is a computed column on top of an existing table. And again, I'm in my local environment. I want to make sure that this thing works. I'm going to create that column, and then I'm going to start building. So the same process what Silvano showed you, but thinking about multiple developers doing that, right? Build works because it's, again, local. Everything is good. I'm going to go ahead and actually publish that. From a publish perspective, and in this case, this is the local container that will show up, and it should reflect the changes that I've made. Now it's ready to be published, so you can choose to actually publish to emulator. And again, in this case, another person working on their computer, they can keep testing it and evolving upon your DevOps lifecycle. You can imagine this, like every developer is doing that, and highly recommend you to do that more frequently. So don't wait for the end of the week to do your check-in, so there are less merge conflicts and things like that. So in this case, on the other side now, I've got the CSAT SQL with the new column added. You can see that it's reflected here. Now I'm going to go ahead and actually start thinking about how do you kind of publish it from an existing SQL schema or existing database that already exists. So you might have already have something deployed in your target environment in Azure that now they may be built upon, right? So in this case, I'm just showing you that this column is actually reflected and it's done. In addition to that, you might have a new idea for writing a new stored procedure or some other thing that you need to add. Maybe previously you were reporting on quarter, now you want to do it on monthly basis or vice versa, things like that. So you're going to go ahead and start doing that changes right here as well. Let's get there. So in this case, there's the other process as well. You want to make sure your project is also up to date from the database side. So if there are other changes happen that you're not aware of, the life cycle needs to be updated. Your local project needs to be updated from the database side of things as well. This will actually do that. It will show you the source and target, make sure, and side by side in the tool itself, you can see what are the changes. In addition to all of those changes, think about scenarios where you have variables, right? So I'll pause here and explain that in a second. So if, for example, you have a dev environment and UAT environment, production environment, we highly recommend you to think about variables. So you only change as part of your development lifecycle the variable values, where you're deploying it, testing your schema changes, any other code changes. So as your thing gets more mature, you need to think about all of these things where you can move from one environment to your final target production environment without making a lot of changes in your code. So in this case, that was the example of a variable also that changed or some other updates were happening. Now again, from your lifecycle perspective, you're testing on your local machine, making sure it's working, and then you add to connection to confirm that it's working on the system as well. Now these changes are done. Now I'm going to go ahead and do another change, which is adding a new stored procedure, right? So right now we were doing the reporting by month. Now some leader in your team wants to see this report by quarter. So you actually reuse your existing stored procedure and rewrite it to update it by quarter. So that's the change we're going to quickly do, write a new stored procedure, report get CSAT report by quarter. It will take a few seconds to do that. Just add a new stored procedure, name it whatever you want to name it, and then add the code that you want here as well. So this is good. Now we're just going to update it with the quarter changes, and then make sure that it's reflected as well. You're happy with the stored procedure, same process starts, right? You need to make sure that you kind of do incremental changes to your target environment as well from time to time. From your local environment, do the build, do the publish, and then keep working on it. In this case, I'm now publishing to an existing database environment that is already in sync, because I did that a few minutes ago. It will generate kind of the script and the changes for you, and then you can see any errors, any issues that are there as part of that. Now, that's the typical DevOps lifecycle. It can get as complex as you want it to be. You want your developers to talk to each other. You want your DBAs to talk to the developers, and that's the point of what I'm trying to show here, that can get super complex as you are working in different teams and all of that. Now, all of this looks good. I'm ready. So now I want to be, again, cool again. Think about the whole life cycle of using GitHub. In this case, I'm using GitHub Actions from the DevOps lifecycle. So here, I'm going to go ahead and create basically the YAML file from, so this one I'm still showing you the difference that shows you from side to side in the tool that you have made this change, and this is the stored procedure change that you have made. Now the YAML file is right here, which is ready to get deployed, and this is part of the GitHub Actions. So all I need to do is actually, again, publish this as part of the GitHub Actions, and it will show up in my GitHub repository. From there, you can, like, this is the whole process of taking it from development to actual testing and your production environment. You can keep doing it. You can have different kind of checks and balances as part of your GitHub Actions. If you want to do a UAT test, a post-deployment, pre-deployment script, you can make it as complex as you want it to be. In this case, just kind of publish it. As soon as you publish it, you would be able to see that. That's the commit I just made. And then from that commit perspective, you'll see that YAML file is deployed, and the build and deploy is started. You can go in and check that it's ran. If it's not ran, if there are any issues, you can fix those issues, and you're good to go. So taking from a local development environment to actual continuous kind of CI/CD, testing it, making sure you kind of repeat it all over and over with different developers, talking to each other, talking to your DBAs, and then eventually adding it to your GitHub lifecycle as well. All good? Ready for the next?
Cool. Thank you, Mazma. So you saw how you started from a small scale of development environment, built all the APIs that you need, did all your DevOps, created all the complex architectures that you needed to create to be able to create a really modern enterprise class or all customer class apps. Now you're ready to do, if you want to deploy this in the cloud, you want few things. You want things that, okay, I make this available to all my users. What does it mean that tomorrow I could start with few hundred users, I could end up with million users. I could start with a 10 gig database, it could end up with a terabytes of database. I could need small processing power today, I could need tons of processing power tomorrow. My workload could become variable. It could be hot during the daytime, it could be not so hot during the night time. It could become even hotter during the Christmas time, it could become cooler during the spring break. All these things could have. You need to think about all this. Where will my resources come, how big the resource needs will be. And you want to rid yourself of all this stress that when it is running in production, I should get as much resources as I need, but I'm not burning resources when I don't need them. But I should not be bottlenecked or boundaries in a bucket where I do not have room to grow and play. So now, with this, Denzel is here to show you what are the kind of database capabilities that you look for, how will you scale, how will the system scale for you, and whatnot.
So hi, so I'm going to introduce hyperscale, and you've seen some of this in a keynote demo, but there are a couple aspects of this I want to show, right? So hyperscale is the place to be, whether it's starting small or the database is growing. It gives you separation of storage and compute, ability to scale out, ability to now have auto scale with serverless and a bunch of other things to go with it. So here I have a database which is a hyperscale database. It is provisioned here, but you have the option of serverless, and I'll show a serverless version of this as well. Right now it's on generation 5, but you have premium series capabilities as well. And it's configured at 20 vCores because we're going to see some scale aspects of it. Right? So if you look at replicas tab, you see this database has a primary with a high availability replica, which is provisioned. And then you have a named replica, for those who don't know, that enables read scale scenarios. All the APIs, servicing read APIs and all can be done with read scale. This is a serverless version with 20 vCores. So I'm going to show you a couple aspects. Let's say I start with a single node. I don't have any scale. So I have a read-write workload all going to one node. Right? So I'm starting this workload. And, I want high availability, so I have a high availability replica, but everything goes to one node. We are throughputing about 22,000 transactions per second. Workload is going great, but at some point I hit a bottleneck, right? And the bottleneck here is your CPU is at 100%. So you're not going to be able to scale much further as the app grows because your CPU is pegged. Well, you're getting a bunch of transactions per second, but what if you want to scale? What are your options in terms of scaling? And there are multiple options in terms of scaling. If you see inserts, updates, deletes, which I'll show you later will scale up, we are generating about 11 or 12 MB of log per second. And total batch requests are closer to the 40,000 batch requests per second. And this is on one node, all workload, read and write, going to one node. Right, so I'm going to stop that now and show scalability with serverless read scale. Yeah, so what I'm going to do from an app perspective, I have the read-only workload now going to a read replica. With, from an app perspective, I know what my read paths are, and my write workload going to the primary. So I'm segregating both of those to allow scalability of the platforms, right? So I get 11,000, 12,000 batch requests per second on the primary, and I'm still maintaining that 40,000 on the read replica. So I offloaded all my reads to allow the system to scale. Now, if we look at resource usage in a second, you'll see that the secondary is pegged right now, but the primary has much more headroom. We're generating more orders per second, if you will. All your write workload is increased. We're generating more log, which is number of changes per second being generated. And we have freed up some bandwidth on the primary, which is the most important thing to get incoming orders, book orders, if it's a book system or whatever. Right? On the serverless, this is a serverless thing, so your build only as read APIs are actually serviced. You're not otherwise. We have the same amount of throughput. Sure, it is pegged, but we could increase, add a replica to alleviate any pressure on read workload. And this is a serverless, which is built on a per second basis. There's instant scaling. When you were not using it, you were not being charged. There's instant scaling as the workload comes through and uses the resources. The last thing I'm going to show, and like I said, the last thing I'm going to show is a provisioned read scale replica versus a serverless read scale replica to show you that we can sustain the same amount of throughput in provisioned versus serverless, right? And so I'm going to run these side by side, my read workload going to both. And you'll see that the throughput is roughly kind of the same. We're in the 32,000, 33,000 across both, right? Now, but in one case, provisioned is billing you per hour, right, based on provisioned cores, whether you use it or not. In the other case, serverless is billing per second as resources are needed. But you'd see, throughput-wise, it's really the same. Of course, serverless does have a little less memory per core. So there might be workloads where provisioned, if you have steady state, you're always at peak state, it'll be better. But in serverless, you'll see at the time we're not using, we won't bill you. At the time we're using, the scaling is almost instantly. When we're not using, again, we trim down the CPU need and memory need. And so it's very responsive to workloads without connection drops and things of that nature. For most part, as the workload scales, you get billed. It's almost instant auto scale. As it drops, you see memory drops too. We reclaim caches, and you're not billed. And it allows independent scaling of CPU as well as memory, right? And more importantly, I don't know. Oh, yeah, most of your memory actually, as you can see, as we're ramping up the workload, comes from a buffer pool, which is to cache pages, right? And scalability is pretty instant from that perspective. Now, from a billing aspect also, you'll see that the billing is on a per replica basis that serverless is configured for. When if you look at CPU and memory percentage, as CPU and memory percentage rise, then the app CPU build, which is the billing per second, will rise. When it's not used, you're billed for the minimum vCores configured. And so this is how serverless really helps you, in particular in these cases where you have a spiky type workload, as your workload is growing, you have periods of the day which are busy, you're billed for only what you use, helps you, even build per replica use. So if you have, for example, a primary and an HA replica, if HA replica is only doing log apply, you don't have read workload, then that HA replica is built for minimum vCores, whereas primary is built for whatever is being used. So here's how you can use, hyperscale. Here's the definition of min and max vCores, which allows you an 8x factor from min to max. So you can have 2 as a min and 16 as a max, or it's 8 times the scalability for auto scale in the system.
Cool. Thank you, Daniel. So now, starting from the classroom, you have already been step by step building your application and scale it to a global scale. Now you are able to run transactions a lot. You are able to have an application which is very, very successful. Now is the time to go to the boardroom, to actually either you're presenting to either as an IPO to raise fund for it, or you're trying to build a business case to expand your business global, or you're looking for funding to hire more people to grow. So what do you want to show? You want to show some analytics capability in your database to show, okay, you see I have grown my user over a period of time. I have grown my transaction volumes over a period of time and how I have done it. So to bring in, show you some analytic capability so that you can impress your board, here is Chuck to walk us through.
Why did you waste my time with most of these people? You're coming to me for funding. The only thing that I care about is what this guy was talking about, saving money.
See?
I want to see charts. I want to see graphs. I want to see pretty pictures telling me where my money's going. All this developer stuff, nah.
Take it over and show them over. One thing is for sure, when you go from classroom to the boardroom, so far I was thinking that you grow hair, but you grow hat.
Remember, from the keynote, the enemy of the developers? All right. So what we are here to talk about is translytical workloads. Those workloads that allow you to do analytics on your transactional systems without having to offload to a separate system. The goal here, do as much as we can, as cheaply as we can, without having to duplicate data unnecessarily. All right? So here we go. What we have here, we were just talking about read replicas and that. I'm running a managed instance for this demo. So we've got a primary server. We have a secondary in-region synchronous replica. We have a geo-secondary asynchronous in a different region. So what does that give us? It gives us our HA. It gives us our DR. It also gives us the ability to read from these secondaries and offload our read workloads. Denzel was talking about that a little bit. It's a great way to save some costs by using your DR or HA systems rather than just letting them sit there, letting them actually do some work for you. So you can see here, I'm connected to my primary. It's in read-write mode. If I switch over to my other management studio, I'm connected to 2 different servers here. One of them is my in-region synchronous replica. If I run this, you can see that it is in read-only mode. Then the other one is my geo replica, which is also going to be in read-only mode when we get to that query. So what you can see here on the left-hand side, this is a power meter scenario. We are gathering data from IoT-based power meters. We want to be able to ingest this data fast, but we also want to be able to keep that history data available for use in our reporting systems. So the meter measurement table, here's that, the read-only geo replica. Our meter measurement table and our meter measurement history table are a temporal pair. Remember having to write triggers to manage your history as data changes? This takes that away from us. We don't have to do that anymore because as we put new data into the primary table, SQL Server is going to automatically take the history data and store it in that history table. The nice thing about this, these are two different storage formats. The primary table is an in-memory table. Great for high throughput ingestion. The history table is stored as a cluster column store index. That's going to be great for our analytics. And through what we did with these extensions in SQL Server, you can go for point in time. You could get all this information. You can go after whatever you need to go after because this is all, to you, it looks like a table. To your analytics engine, it looks like a table. You just need to not pause the video. So you just need to go after it. So what we can do here, and I just got the 5 minutes, so I'm actually going to zoom ahead a little bit. There we go. So I've got a simulator here to simulate injecting power meter data into these tables. So this is writing into the primary. It's aimed directly at the primary for writes. And if we come into Power BI, we can see that start out empty, our table started empty, but when I refresh this Power BI report is in direct query mode. So all of these queries are running directly against our database server. As I click around in this report, all of those queries will be run directly against the database server. So you can see I'm about to do a refresh here. We're going to get our first load of data off of that server. You'll see all of our charts, all of our graphs populate. And as we click around in the zip codes and apply our filters, each one of these is issuing the query against the back end. So you'll see the time scales change. It's not just the data that's changing, the time scale is changing because we are getting fresh data from the database every single time. Now, how am I saving money here? This is running against my DR site, my asynchronous geo replica. All of these report queries are running against that server. So I'm offloading this. I'm not taking any additional processing from our primary. And if you can see here, I have one of the tables listing out my primary server and where it is, one of the tables listing out my secondary server and where it is as far as data sync. Since it is asynchronous, you are looking at the probability of being out of sync. How out of sync you are is going to depend on how busy your workload is and your network traffic. But if this is something that your reporting workloads can handle, if you can handle being a little bit out of sync from your primary for your analytics purposes, this is a great way to reduce costs and reduce load on your primary. And I say reduce costs because as you reduce that load, you don't have to scale that thing up higher to get your analytics running. And this will make the boardroom happy. Saving money. Remember, pie charts sell.
Cool. Thank you, Chuck. Okay, we have a few minutes to take any questions. Any questions online? Okay, no, that's okay, good. Any questions, folks? I hope you saw the journey from starting with nothing and starting building applications from scratch in Azure SQL DB, going through the building applications, scaling it, going through the DevOps, and now being able to produce the nice visuals and chart and analytics that you need to impress your boardroom to be able to get the funding, get the growth, get the support that you need. I have the panel here, so if you have any questions, we'll be very happy to answer. We'll be hanging around here a few minutes in this room and few hours there as well. Feel free to come and catch us.